Okay, so here's the type of question we're going to have. So in this question here, we have a teacher who runs an online coaching program
Dakota, are your girlfriend's dad and Denise and Savota's dad brothers?
Yeah.
Okay, so a teacher runs an online coaching program, thinks his students' scores are higher. The teacher picks.
Hey Stu, you probably shouldn't.
Oh. Yay!
Because all the different else have stats today.
Yay! Let's open the windows and throw someone out. I got it.
What just
The
how?
power's out.
But don't worry, our fan's still going.
Yeah.
Don't worry, our solar energy.
Solar fan. We'll power the school with.
So the teacher picks a random sample of 100 students. And when we do that, then the mean of that sample, those 100 students, is 562. Okay, now the question always comes out. Is 562 enough above the 530 to say that what she does is making a difference?
Yeah.
Or could that have happened by random? Just by chance of getting a bad sample? We're going to go through this whole steps of this. The first step is you want to write your hypothesis. So your hypothesis would be what?
The alternate.
The
So
first
the
hypothesis.
first degree.
Okay, so what will be the null hypothesis?
Did you have the right one for that too?
Yep. The null hypothesis would be what?
Does not equal.
No, the null is what it does equal. What does the mean supposed to equal?
Supposed to equal.
562.
No, that's what the new
530.
mean is. It should be the mean should be 530.
What? Why?
That's the accepted one.
Coach, student.
So in code students, the accepted mean is 530. Now, so our null hypothesis is that that's what the population mean should be, 530. That's what we know.
For H1,
H1, though, she's claiming that
it's 562.
the mean is greater than 530. We always compare it to that accepted mean. All right, so the question that we ask ourselves in doing this, the question we think about, is the sample mean large enough to reject the null hypothesis?
So H to the 0 is false. Well, how do you know how do you actually know if it's true or false?
Alright, so what we do is, we're going to look at a normal distribution. Okay? We can show you how to set this up. Alright, so first off, a couple things we know. Our sample size was how much? 100, right? If your sample is greater than 30, then the central limit theorem, which we had a couple chapters ago, says that you can use a normal distribution for all your sample means. So all of our sample means would have a distribution like this.
Wait, how is null?
H sub O, yes, is a null hypothesis, yes.
Sorry.
Okay, so in the middle here, our mean should be what?
530.
530. The population mean should be 530 here.
CLT stands for normal distribution.
This is the central limit theorem. It's the one that allows us to use a normal distribution. It says that. Back in chapter 6. And we know the z-score here is how much?
Oh, don't tell me.
What? The z-score? You don't know the z-score.
Well, in the middle we know it though. What's the z-score right here? 0.
Mm-hmm.
Z is 0 in the middle. Okay, now the central limit theorem says that if we plot our mean of our sample, right? Right here, we know that we had x equal to how much? 500 and 562, yeah. The central limit theorem says that the z-score for this is 562 minus 530 over, and then it is the standard deviation for the square root of n. Again, that was back in chapter 6, central limit theorem. So if I calculate,
Test over that?
yeah, if I calculate my z-score, square root of 100 is 10. 2.76. Now, how do I find the possibility of getting that? How do I look at that area, right? I want to find the probability of getting that score is actually this area here.
Wait, what?
That z-score on normal distribution, we can look that up in our table to find that area, right? That's the probability of getting a 562. Right, so let me recap this. If we take a sample of 100 students, and I want the possibility of getting a 562, if the actual mean is 530, and the possibility of getting a 562, we can use our normal distribution to find that possibility, that error, that I should say that probability. So how do I look at this amount here? I mean, what we're trying, I guess, let me see another way to say that. We're trying to say then is this an unusual event to get this mean?
Then how do you say it?
Is that? Well, we don't know until we do some more things. But if we make the assumption that the mean is 530, is it unusual to get a 562?
I would say no, but
Okay, so what we have to do is we need to look up a couple things, and I'm going to kind of run you through the basic ideas now of how we're going to do that. So remember, the null hypothesis, we assumed that this is the mean. Now we're looking at what's the probability of getting one that's this far away out here, right? I mean, if the mean is actually 530, the most probability of getting that is right around 530. We would expect that. So is this an unusual mean?
We believe the mean is 530, so now we're looking for the probability that the mean is 562.
Right. Okay, so kind of here's the basic ideas on this. I'll kind of break this down some more. Now we'll go through them step by step. We are going to reject H, the null hypothesis, if the value of the test statistic, and this is the test statistic here, because I should have labeled this, we call that a test statistic. So the value of the test statistic is unusual. when we assume h of 0 to be true.
Wait, we reject it if we assume it's true?
It's not as unusual when
See, we're assuming h of 0 to be true, and so the question is this an unusual test statistic? Is it rare to get that?
Reject it as valid if
Okay, so a couple more things I'm going to define as I kind of define through this. We have what we call a critical value. Well, I will try to bring all this together. I know it's a lot of things we're throwing out right now. And this is the value that forms a boundary between values that are considered unusual and values that are considered not. So we're going to basically take our distribution and say, okay, anything outside of this value is going to be very unusual to get. And then the critical region is the region that contains the unusual values. And I got one more definition here. We have a what we call the significant level. Or significance level. Significance. Oh, significant. The book use significance. Yep, they use the significance level. Okay, this is a probability that we use to determine whether an event is unusual. And we're going to denote that with an alpha. So basically, our alpha in all this is how strong we want the evidence to be against the null hypothesis.
How what?
How strong. So basically, the alpha is how strong we want the evidence to be against the null hypothesis. And for the most part, you're given an alpha level. Okay, so let me give you an example of some alpha levels. Let's say that we want to basically have alpha, well, let's say alpha is 10%. And let's do a right tail test. So basically alpha becomes, if you look at our normal distribution, we're going to put alpha in the right tail. So alpha will be 0.01 here. What we're going to do then is say that anything that lands in this region here, we will, if we have values that land in this region here, we're going to reject the null hypothesis. And then anything that lands in this region here, we're going to say, well, there's just not enough evidence to reject it. So this will be our, everything else here, this is the fail to reject. That this is not enough difference from the mean that we can say the difference was caused by whatever it is we were doing. Fail to reject in that region. Alright, now, do we have enough time to do another example? Now, I know I'm kind of throwing a lot of stuff at you right now, but our days are limited. Okay, so that first example, I was kind of giving you kind of a rundown. I'm going to run through the steps now of what you need to do to perform a hypothesis test. And we probably won't have time to do a test until Monday. It looks, but this will be section 5, I guess.
What is it, section 2?
Was it 2?
It is 8-2. Only the first one.
Okay, we call it 2 then. I've got just different days of notes here. Okay, so basically the steps to perform a hypothesis test. And we're doing this, again, we're looking at the mean of the data, and the standard deviation of the population is known. Which means that we will later get to one if we don't know that. Okay, your first step is, of course, we already talked about, you're going to state the null and the alternate hypothesis. Remember, the null basically is the accepted amount for the mean. And then the alternate is that the mean is either less than, greater than, or doesn't equal that, depending on what information you have. The second thing, and it says to choose a significant level, but often that will be given. Most of the time in this class will be given. Obviously, if you were not doing a class, but actually doing this for research, you would choose it yourself. That's the alpha. Then what you're going to do then is you're going to find the critical values. You're going to take your normal distribution, split up into where it is reject and fail to reject. or may just be a single value.
So what if alpha's not given?
What?
What if alpha's not given?
Well, for the most part, for this class, alpha will be given. Like I said, if you're doing research on your own, then you would have to come up with what level you want to do that at. You're going to compute the test statistic in this case. And again, we go back to chapter 6, the central limit theorem, which says that on the normal distribution, the z-score we use is the population mean minus the sample mean minus the population mean over the population standard deviation over the square root of n. I'm just about done here. Fourth thing, we're going to determine whether or not to reject. Based on, again, where the test statistic falls, and finally, you're going to state your conclusion. Whether you reject or you fail to reject the null hypothesis. On Monday, then, I'll start going through some examples. So no assignment yet. I'll start going through examples on Monday.